Hey, 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 it's Mr. Pouts. Yay, math. Woohoo! We're going to do section 2.6 here. It's all about ratios, rates, and conversions. So, the rest of this chapter kind of deals with things that deal with ratios, and proportions we'll get to. But we're going to just deal with what ratios are, what rates are, and how we can use some things to convert different ratios. So our goals here, and these are what, just a reminder, you need to have written down on your goal sheet. Okay? You need to write them down and self-assess yourself afterwards. Okay? To find ratios and rates, and also to convert units and rates. That's our goals for today. So as you're writing those down, the situation we're kind of thinking about is one like this. It says 2 Olympic athletes can run the races in the time shown below. So this one is an 800-meter race in 116 seconds. This is a 1,500-meter race in 338 seconds. And we kind of want to figure out who's the fastest runner. Even though they're different lengths, we can figure out on average who's the fastest runner. So that's kind of a goal that we're going to work to with ratios and rates. So a few key terms. And I'm pretty sure at least the first three, I think, are all terms, key vocabulary for the chapter. So I'm going to just tell you, I think these three all have to go on your vocab sheet. But a ratio simply is a comparison of two numbers. Okay, that's what a ratio is. Actually have that written down. Some examples you see, like you write A to B with that, with the colon, you write A to B in the fraction form, or you can just write A to B. Now, those aren't numbers, so actual numbers you could say you're comparing 10 to 5. Usually it has to do with some sort of real thing, or 10 over 5, or 10 to 5. These are different ways to write ratios. All right, next one is a rate. So a rate are more common things that you've seen, like miles per hour, but it's a ratio that compares two quantities having different units. Key part there is that it's two quantities with different units. So if we're saying miles per hour, 25 miles per hour, that would be comparing miles and hours. You could say dollars per hour, gallons per mile, miles per gallon. There's different types of rates you might think of, and we're going to be talking about those a bit. Particularly, we're going to be talking about unit rates, which would be a rate with a denominator of 1. So we're talking miles per hour. That would be miles per 1 hour. So that would be a unit rate. We get paid, a lot of people get paid in dollars per 1 hour. So that would be a unit rate. Most rates that we deal with actually are unit rates. And the last one is called a conversion factor. The conversion factor is a ratio, and this should say of, a ratio of two equivalent measures in different units. So if you're taking a ratio with two equivalent measures, but they have different units. So an example would be, here's an example, 3 feet per 1 yard. It's a ratio. They're two equivalent things. 3 feet and 1 yard are actually the same length, and they're different units. One is feet and one is yards. You could say 60 minutes of 60 minutes per 1 hour. 60 minutes for 1 hour. They're the same length of time, but they're different units. All right. So, first thing we're going to talk about is this thing called finding unit rates, which is pretty much the same thing as just reducing fractions. to the simplest form. And you've done plenty of reducing fractions, finding equivalent fractions that are reduced. So here's our situation that we have. You are shopping for t-shirts, and we want to figure out which store has the best deal. So we have store A, and I'll say store A here. Oops, I'll use a different color now. Store A, store B, and store C. It says to first write each price as a ratio, then write the ratio as a unit rate to compare. So unit rates usually help us compare things better because they both have the same denominator then. So pretty much you're finding a common denominator and making the denominator 1. Okay, so the first one, if you just write it as a ratio, we'll say it's cost of t-shirts at store A would be $25 for 2 t-shirts. And if I would want to get a unit rate, which it says to also find a unit rate, I would reduce it so I can divide both the top and the bottom by 2, because we want to get a 1 on the bottom. So we want it for 1 t-shirt. So I'd have to divide the top by 2 as well. And I can show that here. Divide by 2. Divide by 2. And you end up on the top, that'd be $12.50 for 1 t-shirt. There's a unit rate. So 1 shirt costs $12.50. That's good. We know that. Now store B gives you a deal for $45 for 4 t-shirts. And we want to figure out for 1 t-shirt how much does it cost. So what we're going to have to do there is divide both sides by 4. Or both the top and the bottom by 4, because this would 4 divided by 4 gets you to 1 t-shirt. So 45 divided by 4, and I'm pretty sure it's 40, or it's going to be $11.25, but let's check to make sure. 45 divided by 4 is sure it is $11.25. So that would be $11.25 for 1 t-shirt at store B. So far, store B is a better deal. But we still have store C. So they sell them $30 for 1 t-shirt. Oh no, 3 t-shirts, sorry. And we want to figure out for 1 t-shirt how much it would cost. So this one's a little bit easier. We can divide both the bottom by 3 to get to 1 t-shirt. So we divide the top by 3, and you can do that in your head. 30 divided by 3 is 10, or $10 per 1 t-shirt. Now, honestly, I think all these stores are a ripoff. But if we were buying t-shirts here, maybe they have some designs on them. Looks like store A has the cheapest deal or the best deal. Okay, hopefully the quality is still good. But store A, or sorry, not store A, store C has the lowest price. Per t-shirt. And we proved that because we figured out the cost for 1 t-shirt. Those are called unit rates. Alright? Because they all have a 1 on the bottom. Unit rates. There, there, and there. Alright, that is how you find unit rates. You're pretty much just simplifying the fraction. Okay? I always like to I want to keep it short, so I have one more thing I want to cover. And this would be converting units. So converting units you've done before. Maybe you haven't written it out formally like we're going to write it out right now. But here are the basic steps for converting units. And we got to come up with some conversion factors that we talked about. Or conversion, do we call them conversion factors or for conversion rates? Conversion factors, okay. So we are here. So some converting units. First step to converting units is write your quantity as a fraction. So if it's not written as a fraction, write it as a fraction. Second step, find a conversion factor that includes both units for the situation. So when I say both units, I mean your starting unit and your ending unit, what you want to end up with. Okay, have to have both what you're starting with and what you want to end up with. Then multiply those two fractions together, the conversion factor and the original fraction, so that the desired units are on the top of the fraction. Okay, so what you want to end up with will be on the top of the fraction that you're multiplying by, and then simplify. So let's work through an example like that. We'll do, so it says, what is the given amount converted to the given units? So we want to convert 3 hours to minutes. So let's write it out. Step 1, write your quantity as a fraction. 3 hours over 1. That's all you have to do. Write it as a fraction. Pretty much putting everything over 1. Says find a conversion factor that relates both the units to the situation. So what relates hours and minutes? Well, I think there'd be 1 hour would be 60 minutes. And we're trying to end up with minutes. So step 3, we're multiplying so that the desired units are on the top. So minutes should be on the top. So it'd be 60 minutes would be for 1 hour. We're going to multiply these two together. So when you multiply, you just multiply straight across. So 3 times 60 would be 180. 1 times 1 would be 1. Our hours are actually canceling out here, so we're left with 180 minutes over 1, or just 180 minutes. All right, that's it. We're converting 3 hours to minutes. We're actually writing them as fractions, and we're writing the conversion factors so we can see why it works out. Because the hours on the top and the hours on the bottom cancel each other out. All right, let's do another example. Convert 5 feet into inches. So we have 5 feet, and we're trying to get to inches. So first start with writing your quantity as a fraction. So 5 feet over 1. Now find a conversion factor that goes between feet and inches. I think 12 inches per 1 foot. Hopefully you know that by now. 12 inches would be 1 foot. And we want to have the inches as our desired unit, so we're going to have that on top. So 12 inches for 1 foot. And we're going to multiply these two together. When you multiply, the feet cancel out, 1 on top, 1 on bottom. We have 5 times 12, which would be 60. Bring over the inches as well. All over 1. So 60 inches is our answer there. So there's 60 inches in 5 feet. So if you're 5 feet tall, you're at least 60 inches tall. So that's pretty cool. Now, if you don't know these by heart, here's some common conversion factors that you might use from time to time. One would be that 60 minutes. Here, I'll just start listing them. We have 60 minutes for 1 hour. That's a very common one. There's 60 minutes in an hour. There are 24 hours in a day. That might be a common one. We just did 12 inches in 1 foot. Thinking about that way, we can do 3 feet in 1 yard. Let's see. There are 100 centimeters in a meter. There are 16 ounces in 1 pound. That's another common one, especially if you're doing stuff with food. If you can think of more, bring them to class the next time. Those are the ones that come just to the top of my head. So that's the ones we'll leave for right now. Make sure you have those. Make sure you know what those are. All right, those are common conversion factors. The one I want to leave you with is it says the CN Tower in Toronto, Canada is about 100 or 1,815 feet tall. But how many meters would that would be the tower? So we're trying to go from the feet to meters. And here's the conversion factor. 1 meter to 3.28 feet. So start by setting it up as a fraction, 1,815 feet over 1. And you're going to want to multiply it so that the meters are on top because we're trying to get to meters. So 1 meter to 3.28 feet. And I'm just going to leave the rest to you. Find the correct answer and the correct label. All right. Last thing I want you to think about is any other conversion factors that people would use on a daily basis. So we'll talk about this next time I see you. Have a good rest of your day.